Hello everyone. Today we are going to see on the topic of feature extraction in Tableau. So I am Karthiyan, working as an assistant professor in the Department of Mechatronics. So today we will dive into how to handle raw data and extract the meaningful features and visualize it effectively. So moving to the first topic is introduction to the data preparation. It is more essentially the process of cleaning, transforming, and organizing raw data so it is ready for analysis and visualization. Think of it as the foundation. Without it, your analysis could be built or shaky ground. Why is this is important? Well, it ensures the data quality and accuracy and reduce the error in your analysis and improves the performance of any models you built and ultimately enables better decision making. So look at the cycle diagram here. It shows that how data preparation fits into the bigger picture of the data analytics from business understanding all the way to deployment. So in automation system where data comes from sensors and machine, this step is crucial to avoid garbage in and garbage out. So now let's break down the key steps in the data preparation. First, you need to gather the data from multiple sources like databases, IoT devices, or spreadsheet. So this might involve integrating the different formats uh, that will handle the next different formats. Next, we will can handle the missing values and outliers. So missing data can skew the results. So you decide whether to fill them in or remove them. So outliers are those unusual points that don't fit the pattern. So we will talk more about the detecting them soon. Finally, normalizing and scale features. Features might be on different scale, like one in meters and another in kilometers. So, scaling ensures they are comparable. Again, see this cycle. Data preparation is the step 3, feeding into modeling and the evaluation. So, in this slide, we can elaborately discuss about the cleaning techniques. So, which is a core data cleaning technique is the core part of the preparation. For missing entries, you can delete them if they are not critical or impute them using mean, median, or mode replacement. For instance, you have a data sets of temperature and one reading is missing. So replacing it with the average might make sense. So, then identifying unusual data points or outliers using methods like z-score, which measures how far a point is from the mean in a standard deviations, or the IQR method, which looks at the interquartile range to flag extremes. Here's a diagram showing the outliers in a scatter plot. See the red dot. It could be an error or something insightful, like a machine fault in an automation system. So lastly, scale features to similar range. That is minimum or maximum scaling squeezes the value between 0 and 1. Why? The Z score standardized to a mean of 0 and standard deviation of 1. So this prevents features with a larger range from dominating in models. So the process diagram here illustrates cleaning from raw to the standardized data. So in next step, we are going to see that data transformation methods. This is where we reshape the data to make it more suitable for analysis. So we normalize feature ranges and use standardization technique to bring everything to a common scale as I mentioned. For categorical data, convert the text to numbers using one hot encoding, which creates binary columns for categories, or label encoding, which assigns numbers to labels. So, to reduce the feature space and avoid the curse of dimensionality, we use methods like PCA, LED, LDA, or TSNE. More on this later. So, and here's a list of key transformation techniques, that is data smoothing to reduce noise, attribute constructions to create variables, like data generalization for hierarchy based grouping, aggregation to summarize data, discretization to bin continuous values, and normalization to scale. This graphic shows them visually super helpful for remembering. So shifting gears to the feature extraction, this is the process of creating new feature from existing data to boost the model performance. So it reduces the dimensionality and the complexity, enhances accuracy, speeds up training, and reveals hidden patterns that raw data might hide. So compared with feature selection, selection reduces irrelevant features while keeping the originals, like picking the best ingredients. Extraction transforms data into lower dimensions and create new features, like blending them into something new. So see this balance scale diagram. It highlights the differences. Choosing the right method is key for optimal models in automation, where high dimensional sensor data is common. So now let's explore to the specific feature extraction technique. First of all, commonly is the principal component analysis, that is PCA, a linear method for dimensionality reduction that maximizes variance. So it finds new axes where data spreads out most, like compressing images while keeping key info. Look at these plots showing original data transformed. So secondly comes the linear discriminant analysis, that is LDE. This is supervised used for classification. It maximizes the class separability, projecting data to highlight difference between groups, great for fault detection in system. And third is T distributed stochastic neighbor embedding, that is TSNE, a non-linear technique that preserves local structures ideal for visualizing high dimensional data in 2D or 3D. See the scatter plots here, it clusters similarly, points closely. These tools are powerful for handling the complex data in automation analytics. So finally, the data visualization. So this makes data easier to understand, reveals patterns and trends that numbers alone might miss, and supports the decision making process. So common types including charts like bar for comparisons, line for trends, and plot like box for distribution, or heat maps for correlation. So check out these examples. Visuals turn abstract data into actionable insights, especially in the automation dashboards. So here's a Gen AI generated crisp DM methodology for data analysis project lifecycle. It starts with the business understanding, moves the data understanding and preparation, then exploratory analysis, that is modeling, validation, and finally visualization and presentation. It's a greater overview of how all this fits together. Use it as a reference. So, in recap, we clean and transform the data, handling the missing values, extract the features like with PCA, LDA, TSNE, and visualize using charts and graphs to reveal patterns. So, thank you.